So good afternoon to all. So in last class, I have discussed about muscarnic receptors, and there is a 5 types of muscarnic receptors are there. And last class I have covered some pathways also. So M1, M2, M3 receptors pathways, mechanism pathways. So in today's class, I am going to discuss about nicotinic cholinergic receptors. Okay, so acetylcholine binds with the 2 kinds of receptors, that is muscarinic receptors and nicotinic receptors. Okay, if it is binds with the muscarinic receptors means they can show the muscarinic like action. If it is binds with nicotinic receptors means the acetylcholine can be shows the nicotinic actions. Okay, so next coming to the nicotinic receptors, nicotinic receptors are divided to 2 types. Okay, that is NM type and NN type. Muscarinic type of nicotinic receptors and nicotinic type of nicotinic receptors. And what is the exact location of these receptors is what neuromuscular junction. Okay, so the location of nicotinic receptors is neuromuscular junction. Okay, muscarinic type of nicotinic receptor location is NMJ, means it is a site between neuron and muscle. Okay, and the skeletal muscle end plate. And NN type of receptors is present in autonomic ganglion. Okay, and autonomic ganglion is nothing but sympathetic and parasympathetic ganglion. In both ganglions, the NN receptors are present. Okay, and one more thing is adrenal medulla also. Okay, NN type of receptors is present in adrenal medulla and CNS region. Okay, so what is the kind of nicotinic receptors? All muscarinic receptors are what kind of receptors? There is a G protein coupled receptors. M1, M2, M3, M4, M5. Okay, but nicotinic receptors are not G protein coupled receptor. They are ligand gated ion channel. Okay, so what is the type of nicotinic receptor is ligand gated ion channel. So what is a ligand gated ion channel? It's the first type. The receptor subtypes. There is a ligand gated ion channel, G protein coupled receptor, and tyrosine kinase activated receptors. So nothing but enzyme linked receptors. So there is a subtypes of receptors is there. Okay, types of receptors. So in that, the first type of receptor is ligand gated ion channel, and the second type is what G protein coupled receptor. So mostly 80% of the drugs is acted through what G protein coupled receptors. Okay, only few drugs, the 20% of the drugs is acted through enzyme linked receptors and ligand gated ion channel. Okay, so here the nicotinic receptors are the nature of the nicotinic receptor is ligand gated ion channel, but the nature of the muscarinic receptors is what G protein coupled receptors. Okay, so in ligand gated ion channel, so what is the structure of the ligand gated ion channel? Okay, so this ligand gated ion channel, this molecule, okay, so this molecule size is 8 nanometer. Okay, the diameter of this molecule is 8 nanometer, and this one is the rosette like pentameric structure. What? Rosette like pentameric structure. So why? Because they consist of 5 subunits is there, pentameric subunits. So what is that? 2 alpha subunits, okay, 1 beta, gamma, and delta. Okay, so there is a 5 subunits is there, and the molecular size is 8 nanometer in diameter, and this alpha subunit consists of 2 binding domains. Okay, so that is agonist binding domains. Okay, the ligand binding domain means the ligand, it will be binds with what kind of subunits? That is 2 alpha subunits. Okay, this one is in resting state. Okay, here A and B is there. A is nothing but it is resting state, means there is no availability of signal here. There is no availability of ligand. There is no availability of agonist here. Okay, so in B, in this B figure, here it is what will happen. There is an agonist. Okay, so this agonist is binds with what 2 alpha subunits. 2 alpha subunits consist of what ligand binding domain, means the agonist binding site is present in 2 alpha subunits. Okay, so then this agonist is binds with this ligand binding domain. Then what will happen? Acetylcholine. Okay, acetylcholine is binds with 2 alpha subunits. Okay, then what will happen? Then all subunits, okay, the remaining all subunits, it will be move apart. Okay, then opening of the central pore. Okay, so there is an opening of what? Central pore. Pore is nothing but it is a some hole like structure. Okay, and there is an opening of central pore, and the size of that pore is note down 0.7 nanometer. Okay, the pore size is 0.7 nanometer. So this pore is highly enough for the passage of ions into the cytosol. Okay, so that pore is required for the passage of ions. So what kind of ions? Here, the nicotinic cholinergic receptors are non-selective type. Okay, these are the non-selective cation channel. So what do you mean by non-selective cation channel? Okay, means there are not only one kind of positive ion. There is a different kinds of positive ions. It will be moves across this channel. Okay, so the nicotinic cholinergic receptors are non-selective cation channel. Okay, what is the meaning of non-selective cation channel? Not only one type of cation channel, there are different kinds of positive charged ions. It will be moves across this ion channel. Okay, so there is a different kinds of cation channels. There is a different kinds of cations, that is sodium or potassium or calcium. So there is a different kinds of cation channels, cations. Okay, the positive charged ions, it will be enter into the what? Cell. Okay, so as a result of this positive charge, the positive charge inside the cell is increases. So it may resulting in what? Depolarization. Okay, so as a result of depolarization, then what will happen? The muscle, it will be contract. Okay, as a result of this as a result of the depolarization, the muscle, it will be contract. Okay, so here what is that effect? NM type of receptors, muscarnic type of nicotinic receptors is present in neuromuscular junction and skeletal muscle end plate. Then what is that effect is depolarization of the muscle end plate. Okay, so why depolarization is occurs? Because of there is a rapid influx of cation. Because of the nicotinic cholinergic receptors are what kind of receptors? These are the ligand gated ion channel, and this one is non-selective cation channel. So there are several positive charged ions are enter into the cell. Okay, so that's why there is a depolarization thing is happen. So as a result of depolarization, then the skeletal muscles, it will be contract. Okay, the contraction of the skeletal muscles due to opening of the cation channel. Okay, and NN type also. NN type is also present in autonomic ganglion. Okay, both is present in sympathetic and parasympathetic ganglion. Okay, so then what will happen? There is a activation of the postsynaptic neuron also. Both parasympathetic postsynaptic neuron and sympathetic postsynaptic neuron. Both things it will be activated. Because of this, depolarization thing is happens in sympathetic and parasympathetic ganglion. Then what will happen? There is an activation of the post ganglionic neuron. Then that post ganglionic neurons, it will release as the what? Neurotransmitter. So in case of parasympathetic post ganglion neuron is released as the what kind of neurotransmitter? That is what? Acetylcholine. Okay, but sympathetic post ganglion is released as the what kind of neurotransmitter? That is what? Adrenaline, noradrenaline. Okay, and the nature is same. The what? Pentameric structure, five subunits is there. And what is the mechanism is opening of cation channel. Okay, the sodium and potassium, and opening of cation channel, sodium, potassium and calcium channels. And what is the agonist of NM type? That is PTMA. Okay, so what is PTMA? Note down abbreviation of PTMA: phenyl trimethyl ammonium. Phenyl trimethyl ammonium. Okay, and one more agonist is nicotine. Okay, and antagonistic of NM is tuberculin and alpha bungarotaxin. Okay, these are the two agonists. Okay, so this agonist, antagonistics are two, tuberculin and alpha bungarotaxin. So these two drugs are inhibiting the NM type of receptors. And NN type of receptor agonist is DMPP. So what is DMPP? Note down abbreviation. DMPP means dimethyl phenyl piperazinium. Dimethyl phenyl piperazinium. Dimethyl phenyl piperazinium. Okay, and one more agonist is nicotine. And antagonistics of NN is hexamethonium and trimethophan. hexamethonium and trimethophan. So these are the antagonistics of NN type. Okay, so this one is information about nicotinic cholinergic receptors. Okay, so muscarinic receptors are act like a G protein coupled receptors. Okay, they are active through G protein coupled receptors, but nicotinic receptors are the nature of the nicotinic receptor is ligand gated ion channel. Okay, they are only allow the what kind of ions is positive charge ions after binding of the acetylcholine. There is a movement of the, there is a all subunit, it will be move apart. Okay, then the central pore size it is automatically increases. Okay, then what will happen, there is a high influx of what cations into the cytosol. Okay, and next thing is pharmacological actions of cholinergic drugs. Okay, so acetylcholine having two kinds of action, that is muscarinic actions and nicotinic action. If it is binds with muscarinic receptors means they can show the muscarinic like action. If it is binds with the nicotinic receptors means they can show the nicotinic like action. So first I will discuss muscarinic action. Okay, so first thing is organ. Okay, cholinergic drugs is present on which organ, that is heart. Okay, cholinergic receptors. Okay, so in this cholinergic receptors is present in heart region, and the heart consists of what kind of receptors here? M2. Okay, M2 receptors is present in heart. So what is the M2 mechanism? M2 mechanism what? Okay, can anyone tell? Unmute yourself and tell what is the mechanism of M2? It is acted through what kind of receptor, what kind of mechanism? It is inhibits the one kind of enzyme. What is the name of that enzyme? M2 receptors. Can anyone respond? No? M2 receptor. Hello? Hello? What is the mechanism of action of M2? So what kind of receptor M2? Excitatory or inhibitory? Inhibitory. So it is inhibit the what kind of enzyme? M2 receptors. M1, M3 have same mechanism. M2 is another mechanism. So what is the M2 receptors are inhibiting the one enzyme? What is the name of that enzyme? So M2 receptors are, it can shows the inhibitory-like effects. So why it shows the inhibitory-like effects? Because of the M2 receptors are inhibiting the one enzyme. After acetylcholine binds with M2 receptors, there is an inhibition of one enzyme. After inhibition of that enzyme, there is a effect it will be produced, that is bradycardia, cardiac arrest. So what is the name of that enzyme? G protein coupled receptors. Do you know or not? Last class I have discussed, no? M2 receptors, mechanism of action.
Adenyl cyclase.
Yes, good. So what will happen as a result of inhibition of adenyl cyclase enzyme? There is a decrease in the production of what? Cyclic AMP. Am I right? Am I right or not?
Yes.
Yes?
Yes, ma'am.
Then inhibiting the function of what? Cyclic AMP. Okay. And one more thing is, it is potentiation of ion channel also. So what is that ion channel? See this. See. Adenyl cyclase enzyme is inhibited. Acetylcholine after binding with M2 receptors, then what will happen? There is a inhibiting the adenyl cyclase enzyme. There is a decrease in the production of cyclic AMP. And one more thing is there is an activation of potassium channel. Okay, so there is a high efflux of what ions? Potassium ions. Okay, so there is a movement of ions from the inside the cell to outside the cell. Then the positive charge within the cell is decreases. Then it may lead to what? Hyperpolarization.
Okay, so what is the mechanism of action of acetylcholine? Okay, mechanism of action of acetylcholine and heart means what? Because M2 receptors are, it causes the hyperpolarization of the SA node. Why? Because M2 receptors are inhibiting the what? Acetylcholine. After binding with M2 receptor, they are inhibiting the adenyl cyclase enzyme. So there is a decrease in the production of cyclic AMP and increases the activation of what? Potassium channels. Okay, then there is a positive charge within the cell is decreases because of the high efflux of potassium ions. And one more thing is depress the activity of cyclic AMP also. So as a result of these two effects, then hyperpolarization of the SA node is occurs. What is SA node? SA node means what? Sinoatrial node. Okay, so it is a major site. In this site there is a production of the action potential. Okay, so action potential production is occurs in SA node. Okay, so then as a result of this mechanism, hyperpolarization of the SA node, there is a bradycardia is occurs. The force of contraction is decreases and cardiac arrest is also occurs. Okay, and one more thing is it delays the conduction. Why it is delays the conduction? Because M2 receptors is inhibiting the what? Acetylcholine. After binding with M2 receptor, the cyclic AMP is decreases. Okay, the functions of cyclic AMP is decreases. So here the mechanism is there is an increase as the refractory period at AV node. So what do you mean by refractory period? Means after initiation of the action potential, the cardiac cell is unable to initiate the another action potential for a particular duration of time. Okay, so that time is known as refractory period. Okay, so that period time is increases, means there is a time gap in between the two action potential is increases. Okay, so there is a time gap in between the two action potential is increase, means what will happen? There is a delay in the conduction of the what? Electrical signals. Why? Because SA node is a major site. Okay, then what will happen? That AV node receive the electrical signals from the SA node, from AV node to Purkinje fibers to cardiac muscles. Okay, normally the action potential is produced at the SA node to AV node to Purkinje fibers to cardiac muscles. Okay, so here what will happen? The refractory period is increases. Okay, due to inhibition of the cyclic AMP. Due to inhibition of the cyclic AMP, the refractory period is increases at the AV node. Okay, so that's why what will happen? There is a delay in the conduction of the electrical signals. Okay, so that's why the time interval between the P and R wave is also increases. PR waves means what? ECG consists of waves is there. P wave, QRS waves is there. P wave is indicates the atrial depolarization and QRS is ventricular depolarization and AC is a complete cardiac diastole. That ECG waves is there. Okay, so in that the time interval between P and R wave is increases. Okay, and the heart is also blocked. Okay, so this effects is occurs due to what? The refractory period is increases, means there is a time gap between the time gap in between the two action potential is somewhat increases. Okay, so the time gap in between the two action potential is increases, so that time gap is known as refractory period. So in during that time the cardiac cell is unable to initiate the another action potential. Okay, that period is known as refractory period. That period is increased at which region? AV node region and Purkinje fibers region. Then the cardiac muscle cell is unable to receive the electrical signals. Okay, so that's why the time interval between P and R wave is also increases. Okay, and the next action is blood vessel. Okay, and what? Cholinergic agonist action on blood vessel. Okay, so blood vessels consist of mainly what kind of receptors? That is M3 receptors. Okay, so what is the mechanism? So M3 receptors is act through activation of the phospholipase enzyme C. PLC means phospholipase enzyme C. So then this pathway is increases the production of the two secondary messengers, that is IP3 and DAG. Okay, so then what will happen? Acetylcholine action endothelial cell is, it is increases the release of one relaxing factor, that is endothelial relaxing factor. Okay, so normally M3 receptor and M3 receptor action on smooth muscle is contraction effect. Okay, both M1 and M3 receptors are somewhat excitatory receptors. Okay, but M3 receptors is present in endothelial cells. What is endothelial cells? The inner layer of blood vessel is called as endothelium. Okay, so that endothelium is made up of endothelial cells. Okay, so this M3 receptors is present in endothelial cells. So then what will happen? M3 receptors is it causes the vasodilation. Okay, why it is called as vasodilation? Because of this IP3-DAG pathway, it is activate the release of, it stimulates the release of relaxing factor. EDRF means endothelial relaxing factor. Note down, endothelial relaxing factor. So this factor, the name of that factor is nitric oxide. NO means nitric oxide. So this nitric oxide is causes the relaxation or relaxation effect in blood vessels. Okay, so there is relaxation of blood vessels because of this factor, that is endothelial releasing, so not releasing, relaxing factor. R means relaxing factor. R means relaxing. Okay, so then effect is the BP, it will be fall, and flushing. Flushing means about redness because of the vasodilation means what? The blood flow within the blood vessel is increases because of the lumina, the lumina of the blood vessel is increases. Then the blood flow is also somewhat increases. Okay, and in some of the cases, vasoconstriction is also occurs. When vasoconstriction is occurs, note down the condition. Okay, acetylcholine action on blood vessel is vasodilation in normal healthy individuals, normal people. But in some of the cases, it vasoconstriction effect is also produced. When it is means when endothelium is damaged by diseases. Okay. Endothelium means what? The inner layer of blood vessels. Okay, so the inner layer of blood vessel, that is endothelium. When endothelium is damaged by diseases, any other diseases, then what will happen? The acetylcholine, okay, that acetylcholine, it diffused into vascular smooth muscle. Okay, so endothelium is diffused into vascular smooth muscle. So then what is the M3 receptor action on vascular smooth muscle? Contraction effect. Okay, that's why it is called as vasoconstriction. Okay, so here the mainly this EDRF endothelial relaxing factor, it is mainly released in which region? That is endothelial region. Okay, the name indicates itself. Endothelial relaxing factor means the relaxing factor which is it can be released in endothelium. Okay, EDRF. RF means relaxing factor. That factor, it will be released in endothelium. So that's why acetylcholine action on M3 is what? Vasodilation. Because of this nitric oxide is causes a relaxation effect. Okay, so but in some situation, okay, what situation? When endothelium is damaged by the any other diseases, then what will happen? That acetylcholine is diffused to vascular smooth muscles, so it causes the vasoconstriction effect. Okay, so next one, dilation of what? Cavernous sinus means cavernous vessel. Okay, so these cavernous vessels which are present in penis region. Okay, so this cavernous blood vessels which are present in penis region. So here M3 receptors act on penis is erection. Erection means it is a state of what? Enlarged and rigid state of penis. Erection means enlarged and rigidity state. Okay, so in that erection means somewhat enlarged. Okay, so why it is enlarged? Because of the dilation of what? Cavernous vessels. Okay, so as a result of dilation, then what will happen? The blood flow within the blood vessel is increases. Okay, so that's why erection of penis. Okay, acetylcholine action penis is erection, means enlarged in state. Okay, due to release of what? Nitric oxide. That nitric oxide is nothing but EDRF. Next one is action on smooth muscles. Okay, so what is that action? Smooth muscles consist of M3 receptor, but few M2 receptors is also present. Okay, so here what is the effects is it will produce abdominal cramps and evacuation of bowels. So why abdominal cramps and why evacuation of bowels is happens? Because M3 receptors is act through IP3-DHE pathway, it show the contraction effect. So because it is increases the peristalsis. So peristalsis is nothing but the wave-like movements in the intestine. Okay, there is a protection of the wave-like movements. So that wave-like movements can push the contents forwards in canal region. Okay, so that's why there is a evacuation of bowel, it will be happen, and somewhat abdominal cramps is also happens, and sphincters is also relaxed in state. Okay, so internal anal sphincter. Okay, internal anal sphincter, it will be relaxed in state. Okay, so then what will happen? Internal anal sphincter is relaxed and increases the tone. Okay, increases tone, and peristalsis of the GIT is also increases. So as a result of this tone and peristalsis, there is a evacuation of the bubble, it will be happens, and somewhat abdominal cramps. Okay, so internal anal sphincter, note down, internal anal sphincter, it will be relaxed. Okay, so that's why there is a abdominal cramps is happen and evacuation of bubbles is happens. Okay, so internal anal sphincters, it will be relaxed. Why it is relaxed? It is act through M2 receptors. M2 receptors are somewhat relaxant like effect. Okay, so but M3 receptors are contraction effect will be produced because of M3 receptors are act through IP3-DHE pathway, and M2 receptors are inhibiting the adenine cyclase enzyme, somewhat relaxant effect it will be produced. Smooth muscle relaxant effect it will be produced. So here in GIT region, both M3 and M2 is present. Okay, so peristalsis and the gastrointestinal tone is increases via M3 receptors, and the sphincter, the internal anal sphincters, it will be relaxed through M2 receptors. Okay, so then what will happen? The effects is what? Abdominal cramps and evacuation of the bowels. Okay, and next one is M3. M3 receptors is also present in urinary bladder and ureters. Okay, then finally effects is what? Voiding of bladder. So first of all, what is voiding? Voiding means what? The lower urinary bladder. Okay, the lower urinary tract consists of two phases is there. Okay, two phases of activity is there. Okay, so first phase is storage phase. Note down. Internal lower tract of urinary tract. Okay, lower urinary tract consists of two phases of activities is there. That is storage phase, voiding phase. Okay, storage phase is nothing but there is storage of urine in urinary bladder. What is voiding phase? Voiding phase means the urine is released through the what? Urethra. Okay, the urine is released to release outside through what? Urethra. So that phase is known as voiding phase. Means there is a expulsion of what? Urine. Okay, so why it is occurs? Means the person is desired to urinate very frequently. Okay, acetylcholine action on what urinary bladder is, the person is desired to urinate very frequently. Why? Because here it is, the peristalsis movements in ureters is increases. Okay, and the detrus muscles which are present in urinary bladder, it will be contracts. Okay, and the sphincters, it will be relaxed in state. Okay, internal urethral sphincters. Note down, the name of the sphincter is internal urethral sphincters. Okay, and what? External urethral sphincters. Okay, so external urethral sphincter, it will be relaxed in state. Okay, then what will happen? Relaxed in state means there is an expulsion of urine. Okay, so that during the expulsion of that urine means the phase is known as voiding. Okay, voiding means there is a passage of urine through urethra. Okay, that phase is known as voiding. Means the person is desired to urinate very frequently. Okay, why this effect is it will be produced? Due to contraction effect, contraction of the urinary bladder and peristalsis in ureter. And one more thing is the sphincter is also relaxed. And M3 is also present in bronchial smooth muscles. Okay, so the effect is bronchial constriction. Then what will happen? Bronchial constriction and dyspnea. Dyspnea means what? Shortness of breath and asthma. Okay, so as a result of contraction of the bronchial muscles, then is what will happen? Asthma is also produced. And next thing is glands. Okay, so it is also present in glands. What? M3 and M2 both are present in glands. So effect is what? Salivation, sweating, lacrimation, tracheobronchial secretion, and gastric secretion. All gland secretions is increases. So due to what? Gastric glands secretions is increases because this secretion effect is mediated by mainly M3 receptors. Okay, but few M2 receptors is also present, but this secretion effect is mediated by only M3 receptors. Okay, and eyes, in eye region, meiosis. Meiosis means what? Excessive constriction of the pupil. Okay, so this meiosis is occurs due to contraction of the circular muscles of iris. Okay, so this effect is occurs due to M3 receptors. M3 receptors is active through IP3-DHE pathway due to activation of phospholipase enzyme. And one more effect is blurring of near vision and increases the aqueous outflow and decreases the intraocular tension in glaucomatic eye. So intraocular tension is nothing but is the fluid pressure of the eye. Okay, so the force it will be exerted by aqueous humor on the internal surface of the eye, that is called as IOP, intraocular tension. Okay, so then what will happen here? This effects it will be produced due to contraction of the ciliary muscles because of eye consists of M3 receptors. M3 is nothing but excitatory receptor. And nicotinic actions of cholinergic drugs. Okay, so these are all are muscarnic action. What? Heart, okay, blood vessels, smooth muscles, glands, and eyes. Okay, next cholinergic actions on nicotinic means cholinergic drugs is also binds with nicotinic receptors. So the nicotinic receptors is present in autonomic ganglion. Okay, so both sympathetic and parasympathetic ganglions is stimulated. Then what will happen as a result of stimulation? Then the postganglionic neurons is also activated. Then it stimulates the release of another neurotransmitter. Like the sympathetic postganglionic neurons is releases this what? Noradrenaline. But parasympathetic postganglionic neurons is releases the what? Acetylcholine. Okay, and another thing is skeletal muscles. So skeletal muscles, acetylcholine action on skeletal muscle is inotrophoric application of acetylcholine means what? Inotrophoric means what? Note down. Inotrophoric means it is a one kind of transdermal drug delivery system. Okay, transdermal drug delivery system. So in this system, there is a usage of voltage gradient on the skin. Okay, there is some usage of voltage gradient on the skin. So here it is the direct introduction of what? Drug. Okay, direct introduction of the drug through intact skin. Okay, by the application of the electrical current, that is called as inotrophoric. Means it is a one kind of TDS, transdermal drug delivery system. So then what will happen? The contraction effect will be produced. Okay, due to rapid influx of the cation channel. And as a result of intra-arterial injection, there is a twisting and fasciculations is also happens. So what is twisting? Twisting means bend. There is a shape of bend, and in order to change its shape of the particular thing. And fasciculation. So fasciculations is nothing but involuntary contractions and relaxations thing is happens. If it